welcome back to my channel. I'm glad to have you here. Today I want us to look at some of the questions, especially the difficult questions that students were faced with during the just concluded 2025 mock JAMB examination, especially in physics. Now, one of such questions is this. This one says, a wave traveling along a string is described by the equation y as a function of t, x and t is equal to 0.02 sine 5x minus 10t, where all the symbols have their usual meaning. And of course, that one I did not include it here, where x is measured in centimeters, t is measured in time and in seconds, and y is measured in centimeter. Now, what is a speed? What is the speed of the wave? Now, in this case, we have this, and of course, the options must be the correct option must be one of these from A to D. Okay, so just quickly before we start, if you have not subscribed to this channel, feel free to hit the subscribe button, hit the like button, and then share this video with your friend, because a lot of people are finding this question difficult. In case you meet it, this is just 8 days away from the exam. Now let us start. Solution. Now, if you have this, y equals 0.02 sine 5x minus 10t. Now, if you have this, all you need to do is, there are so many wave equations of a traveling wave. There are a lot of them. But then, the principal equation there is, just compare this with the one that says y is equal to a sine kx minus omega t. Just compare this with this. Now, all we need to do is to define what is k and what is omega. Now, we have that k is the wave number. As the wave number, it is equal to 2k, which is the wave number. Wave number, k is the wave number. And then this k is equal to 2 pi all over the wavelength. 2 pi all over the wavelength. Okay. Now, omega is angular frequency, or the angular speed, please. Omega is the angular speed, or the angular velocity. Now, this omega is expressed as 2 pi all over period, or we can have it as omega equals 2 pi f. Now, in this case, all we need to do is, where you have omega, you put this. Where you have the wave number, you put this, and then rewrite this equation. If you rewrite this equation, from there you can now move. So if we put that, we have that y is equal to a sine k, under k we have a 2 pi x all over lambda minus, permit me to clean here. Now, if I should to clean that place, I will have, if I should clean here, I will have, under this, I will have a 2 pi f, then you return your t. Now, compare this with this. If you compare this with this, we can now solve. All we need to do is, since this says find the speed, speed is what we are looking for. And of course, the general formula for speed is v is equal to 2 f lambda, or you can say v is equal to lambda all over the period. These two formulas can go. In other other words, all we need to do is either we find our period. For you to find a period, you now use omega is 2 pi all over the period. So if you want to use this, that means you need to get this period using this. Now, if you want to use this, all we need to do is to find lambda using this, and then find f using this. Okay, I will solve the two with the two formulas. So we now have for f, if you want to find f, that means we will need to use this formula. So we now have that omega is equal to 2 pi f. Now, omega has been given to us. This value here, if you compare this to any value attached to t is the omega. So it has been given to us as 10. So we have 10 equals 2 times the value of pi, 3.142 multiplied by the frequency. Make frequency the subject. Frequency will give us 10 all over 2 times 3.142 will give us 6.284. Now, this over this, 10 divided by 6.284 will give us 1.59 hertz. 1.59 hertz. All we need to do now is we have found our frequency. Let us find our lambda. So if we want to find a lambda, for lambda we have, I will have to divide this board. For a lambda, we use this. K is equal to 2 pi all over lambda. Make lambda the subject here. If you make lambda the subject by cross multiplying, lambda will give us 2 pi all over k, which will give us 2 pi. Of course, 2 pi is this value, 6.284 all over lambda k. K is that value attached to x. That value attached to x is 5 from here, which will give us 6.284 divided by 5. Divided by 5 here. It will give us 1.26. 1.26 meters. Now, having gotten that, all we need to do is please permit me to clean here, because we have taken the question. So we have gotten that. Now all we need to do is bring this equation. V is f lambda, which will give us f is 1.59 multiplied by lambda. Lambda is this value, 1.26. 1.26. Therefore, the speed of the wave will give us 1.59 multiplied by 1.26, and it will give us 2.0 meters per second. And of course, the option that suits this is option C. So option C is the correct answer. Now, I will solve about 2 more questions that came out in 2005 JAMB mock questions. So, stay there with me. Now, we have this question also that came out. This question says, if 2 charged plates are maintained at a potential difference of 3 kilovolts, the work done in taking a charge of 600 microcoulomb across the field is dash. This A, B, C, D. Now, this question, the moment you get this type of question, you pause a little bit and ask yourself, what is this question all about? Now, this question is not all about energy stored in a capacitor. No. Because, for example, assuming we have 2 charged plates, let's say plate A and plate B. A is charged and then B is not charged. In order to charge B, you take B close to this. and then you must do some work in taking this uncharged plate to a charged plate in order to charge it. No. This question is telling us that both of them are all charged. What work can be done in order to maintain them? So in order to maintain them, of course, in order to maintain this charge, all you need to do is work done, and then this work done will now call to mind what potential difference is. Now this is all about potential difference. If we can take our mind back, we'll discover that yes, potential difference is nothing but the work done in taking a charge of 1 coulomb round a circuit, or from one point to another. Work done in taking a charge of 1 coulomb round a circuit, or from one point to another. Whereas the energy stored in a capacitor is the work done in taking an uncharged plate to a charged plate. They are two different things. So in this case, they are charged. Since they are already charged, all you now do is work done is equal to QV. Simple. Work done is equal to QV. Now, in this case, the V here is 3 kilovolts. Of course, you know what kilo means. Kilo means 1,000. That means 3 times 1,000, which will give us 3,000 volts as our V. Now, Q, charge, is 600 microcoulomb, which will give us 600 times 10 raised to power micro raised to power 6 coulomb. Therefore, Q, if you multiply out 600 times 10 raised to power minus 6 coulomb, it will give us 0.0006 coulomb. Now, bring these two together. We now have that the work done there, or the energy stored, is equal to Q 0.0006 multiplied by 3,000. At the end of the day, work done will give us, if you multiply 0.006 coulomb multiplied by 3,000, it will give us 1.8 joules. And this is the answer we get. Please, on no condition should you use work done, which is half QV. No, because if you want to apply half QV, that means you are bringing an uncharged plate to a charged plate. These two plates are charged. Remove this half. Thank you. Now we'll take another question. Now we have this question on the board, and the question says, calculate the EMF of the cell in the circuit above if its internal resistance is negligible. Now, what we have here is, if you look at this is a parallel circuit. Now, if you watch the video I posted last fall, I will drop the link in the description below. They are described one of the conditions when we have a parallel circuit. Now, one of the conditions is that the same PD flowing in this 3 ohm resistor will still flow here. Therefore, we now say that yes, the E here is equal to E1, which is equal to E2. The EMF flowing into this one is equal to EMF flowing into this one, as well as the potential difference V. Okay, in other words, once you calculate the potential difference here, it is equal to that here. Now, which will now give us that E is equal to, of course, we have I on the board. From here, we have that I is equal to 4 ampere. Now, R is equal to 3. Now, in fact, this is all we need to do is to resolve. Once we resolve it, we now have if we resolve this, R1 is equal to this, and then R2 is equal to 6 ohm. Now, if we have this, what all we need to do is 1 over r is equal to 1 over r1 plus 1 over r2, which will give us 1 over r equals 1 over 3 plus 1 over 6, which will now give us LCM of 3 and 6 is of course it's 6. Okay, now 3 into 6 is 2. 2 times 1, 2, plus 6 into 6, 1. 1 times 1, 1, which will now give us 3 over 6. Now, and 3 over 6, therefore, r will now give us, by reversibility, once you reverse this, make r the subject, we'll now have 6 over 3, which will give us 2 ohms. 2 ohms. Therefore, having gotten r to be that, we now have that E is equal to IR. V is equal to IR. Which will now give us current is this. Current is 4 times R2, which will give us 8 volts. Of course, the correct answer here is D, because because this is parallel circuit. Resolve this, multiply by this, and it will give us all we need. Okay, now the last but not the least. Remember this video, I'll be doing it progressively as we get other questions. Now the other question that was asked, they said, what will be the color of red rose on a blue light? The color of red rose on a blue light. And of course, that will lead us to the 3 primary colors. The 3 primary colors are the red, the 3 primary colors are red, blue, and green. Now, the color of an object is highly dependent on the light falling on it. Simple. And then, that is one. Secondly, it is dependent on the color that it is reflecting and the color it is absorbing. Ordinarily, red rose has these 3 colors in them. But because of white light shining on them, these 2 are absorbed while red is reflected. Now, in a situation whereby instead of white light falling on it, blue light is now shone on this red rose. In other words, these 3, all of these 3 will now be absorbed, and the only color that will be reflected is black. That is what you will see. So, in other words, when blue light is shone on a red rose, it appears black. Okay. Now, please, if you have not subscribed to this channel, do me this favor, hit the like button and then subscribe to this channel, so that subsequent lessons you get them, especially those more questions. I'll be dropping questions every day. Remember, this is just 8 days away from the D-Day. I'll be dropping questions. Now, feel free to join our free online class. There is a link in the description below, and at the same time in the comment section. Join that link, and then you will join our WhatsApp classroom. Thank you.